Hello, so today we will learn how to find the roots of your quadratic equations. Okay, now remember that when we speak of the roots are the answer to an equation. So we call this as the roots of your equation. Now remember, when we are solving quadratic equations, we use the quadratic formula x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now, the terms inside your square root is what we call the discriminant. So the discriminant is b squared minus 4ac. Now, why is it important that we need to understand what a discriminant is? It is because the value of your discriminant will tell you the nature of your roots of the equation. Okay, so for the first one, if your discriminant is greater than 0, then you will have two real distinct roots. That means different roots. Okay, and if your discriminant is equal to 0, then you will have two equal roots. So in the end, you will have one root left because they're just equal anyway. And if the discriminant is less than 0, that means the discriminant is negative. And remember, when we are taking the square root of a negative number, it will give us an error, right? When you input this in your calculator. So therefore, if the discriminant is less than 0, then you will have no roots, right? So how are we going to apply this in our examples? Let's say, for example, you are given with this item number 1. Find the values of k for which this equation has two distinct roots. Now, remember from the table earlier, the only time that we will have two distinct roots is when the discriminant, which is b squared minus 4ac, is bigger than 0. So we need to make sure that the discriminant is greater than 0. So when will that happen? Now remember, the coefficient of your x squared is the a, the coefficient of x is the b, and the coefficient, and the last constant here is the c. So we're going to substitute these values. So that will give us your b is just positive k squared minus 4. Your a is k plus 1. Your c is negative 2k. So don't forget to bring the negative signs. So that will be greater than 0. So simplify. Negative 4 times negative 2 is positive 8k. So just put it like this first. K plus 1 is bigger than 0. So this will give us k squared plus 8k squared plus 8k is bigger than 0. So in other words, what we will have is 9k squared, okay, plus 8k is greater than 0. So now this is a quadratic inequality. Now how do we do this? So that will give us, so 9k squared plus 8k, we can factorize your k, and that will give us a 9k plus 8 is bigger than 0. So therefore, your value, when will this be greater than 0? So as you notice, this will be equal to 0 when k equals 0 and when k equals negative 8 over 9. So what we're going to do is we are going to graph your quadratic inequality. So remember, it passes through negative 8, 9, right? Because it will be 0 at the y value will be 0 for these values of k, so that's 0. Now notice the a is positive, so it is opening upward. So we will graph it opening upward. So it will be like this. And what we want is something that is greater than 0. So that means That means it's above the x-axis because the y value must be greater than 0. So therefore, can make a conclusion now that the values of k we're in, we will have two distinct real roots are less than k less than negative 8 over 9, or k is greater than 0. All right? Now, let's proceed to question number 2. So show that the roots of the equation, this equation here, are real and distinct for all real values of k. So what we're going to do is, remember again, for this to be distinct, our b squared, which is the discriminant, minus 4ac, is greater than 0. Okay? So now take a look. What is our b? Our b is, oh sorry, there should be a 5kx here. So our b is 5k bracket square minus 4 times k times negative 2k must be greater than 0. So will it be greater than 0? Let us check. So that will give us 5k squared. This is a plus 8k squared, right? Is greater than 0. So that will give us 13k squared is greater than 0. So now the question is, for all values of k, will this be true? So will this be true? So ask yourself, is this true all the time for all values of k? Definitely, it is true because k squared, right, is always positive regardless of the value of k that you need to substitute. And that means multiplied by 13k squared. So 13k squared is always positive for all values of k.